Okay, we're going to solve two-step equations today. So kind of want to think about an equation as like a balance scale, or if you remember when you're a kid, the seesaw at the park, teeter-totter sometimes they're called. You want to keep it balanced. If one end is heavier than the other, it won't be balanced. With an equation, we want both sides to be the same weight, you might call it. So taking a look, back in junior high, you may have used symbols, that kind of thing to show algebraic expressions, and in this case, equations. So we've got 4x plus 2 equals 10 is the equation. Symbolically, it's here. We've got 4 blue x's. Here we go. There. Plus two ones. And then we've got 10 ones over here. Okay, so if we want to get the value of x, we want to get rid of these two green dots. So you can see here it's getting rid of 2, which means to keep it balanced, we have to get rid of 2 from, so you can see they came right from there. So now what we're left with, so we've subtracted 2 from both sides of the equation. So we're left with 4x equals 8. And now we want to divide the 8 into 4 groups. So you can see in the diagram there's 4 groups, 4 x boxes, and so each group, each x is 2. And so what we're doing in the equation is dividing by 4. So x equals 2. Okay, so really that's the opposite order of operation. To build an equation, we follow the normal operation. So we start with x, then it was multiplied by 4, and 2 was added to get 10. So that means to go backwards, we've got to subtract 2, divide by 4. Opposite order of operations. Okay, so let's do some practice. So here I like to circle the term with x in it, especially if there's just one term. And then I know I have to get rid of the minus 3 by adding 3, do the opposite. So then those go to 0. So then 7x equals 21. Then I divide by 7. Opposite of multiplying by 7 is dividing by 7. And so then x equals 21 divided by 7 is 3, right? Because those are divided out. Next one, circle the term with x in it. Notice how it's a negative, so I'm going to keep that. Oops, I'm going to then get rid of the 9. So if it just says 9, the opposite is subtracting 9. Both sides. So I'm left with negative 3x. And then 21 minus 9 is 18. Divide by negative 3. Those divide out, so I've got x equals negative 6. Now, the next one has two terms with x in them. So here, I notice on the left, I've got an x term. So I'm going to leave it there because it's already by itself. This other x term, though, I need to get rid of it. So I need to subtract 3x from both sides so that that goes away. So then 5x minus 3x is 2x, and the 14 is still there. Then I want to divide by 2. So x equals 7. Here, there's x on both sides. The right side has an x term, so I'm going to leave the 8x there. Then I'm going to subtract 5x, because I can't have x's on both sides. And then I'm left with 27 equals 8x minus 5x is 3x. And then I'm going to divide by 3. So x equals 9. Same in the next one, two terms with x. Going to leave the 2x on the right. Now that's minus 6x, so I'm going to add 6x to both sides. So that adds to 0, so I'm left with 24 equals 8x. Now here, got to get rid of the 8. And notice how I did it on the last one as well. So here, this is 3 equals x, but I don't like to show it that way. We always like to have x equals first. So I'm just taking that equation and reversing the whole thing. Okay, and the last one I did it right away, because once you get used to that, you'll do it in your head, not show it twice like this one. But really, it's better to say x equals 3. Just like I say, my name is Ms. McKay. I don't really say, Ms. McKay is my name very often, right? So there's sort of an order that makes sense. This next one has brackets just for integers. So I'm going to just show this same equation again by knowing that subtracting a negative is adding. And now it's just like the other ones. I've got x terms on both sides. I'll keep the 4x on the right. I'll subtract 7x from both sides. And then I'll divide by -3. So I'll get x equals -7. Okay. So then switch over to the next page. Okay, so in G, some view is helping a little bit. We want to subtract 8x from both sides. So that goes away. You get 4 equals -6x. Then you got to divide by -6. And so then we get x equals, and we have to simplify that 4 divided by -6. So it's going to be a negative. 2 goes into 4 twice, into 6 3 times. So you just want to reduce any fractions. Don't tell me the decimal form. So don't put 0.6 repeating or round that to 0.7. Keep it as a fraction in lowest terms. In 8, remember my hint, get rid of the brackets there. So adding a negative is subtracting. Oops. And now again, we want to get the x's together. So I'm going to add 7x. Divide by 3, and you can't simplify that. It's just going to be 8/3. And that's okay. It's okay to have fractions. So the title of this note was two-step equations, because really we were doing 2 steps, except for maybe that one where we got rid of the brackets, but we were adding one term, both sides, and then dividing, okay, whether it was an x term or a constant term. Now, actually, this one here is just a 1 step, but then we get 2 steps. Notice how these have fractions. So they're starting out with x divided by something rather than what we had before was multiply. So what's the opposite of dividing? Multiplying. So here, to get x by itself, we're going to multiply both sides by 4. Okay, so when I do that, I get x equals 80. A really common answer that I will see is students just say, oh, that's 5. Because they see a 20 and they see a 4 in the denominator. And 20 divided by 4 is 5. But if you put 5 back in for x, 5 divided by 4 is not 20. Right? It's 1 1/4 or 1.25. So that was really a 1-step equation. This one's a 2-step. We want to get x by itself. So we're going to subtract 5 from both sides. And 17 minus 5 is 12. Now, Answer, if you put 2, is incorrect. So think, why did you get 2? If you got 2, you said 12 divided by 6, and that's not what it is. It's x divided by 6. So we have to multiply both sides by 6. And so that's 72. We need a big number for x so that when we divide by 6, we get an answer of 12. Sometimes when we get a little bit lazy, we just sort of skim or don't look closely at what's happening. So don't just assume that it's 12 divided by 6. Okay, next one. Subtract the 4 because we've got to get the x term by itself. Oops. Okay, and then multiply by 3. Okay, and then this next one has 2 terms with fractions. Luckily, it's nice. They both have denominators of 5. So they're like fractions. Okay, so when they're like fractions, you can add the numerators, keep the denominator 5. X plus 2x is 3x. Okay, so simplify those like terms. Both of them had x's in them, so I want to add them. They both had the same denominator, so that was nice. Now this one, all the other ones was x divided by a number. Now this is 3x divided by a number. I'm still going to do that same step of getting rid of that denominator, because really, who likes fractions that much? Get rid of the denominator if you can. You can only do this when you're solving equations. Obviously, you can't just get rid of a denominator if you're adding and subtracting fractions, but you can for this. So the 5's divide out. 12 times 5 is 60. And then we can divide by 3. Okay. Same thing with the next one. There are 2 terms with x's, so we want to collect those. So I'm going to subtract 4x over 6 from both sides. And think about it. Again, same denominators, which is very lucky. They're not all like this. As you go into 10C, you'll get more challenging equations. We'll do a few more challenging tomorrow, but sort of a different type of challenge. In terms of fraction questions, more in 10C and then in higher grades. But here, same denominator, and then 5x minus 4x is just 1x. So we don't have to show the 1. Just remember that from your algebra skills. If you've got 1x, it's the same as just x. Just like saying, I have 1 cup of coffee is the same as saying, I have a cup of coffee, right? So you don't have to show the 1 there. And then I'm going to multiply by 6. Oops, let me do that in red. So x is negative, what is that, 54. And then another one with two fractions. Again, I've got an x term on the right, so let me get rid of the other x term on the left. And then luckily, so I'm not making you have different denominators. You can subtract those right away. Question? Yeah, just sign out at the front there. So 2x minus 4x is negative 2x. And again, get rid of that denominator. Denominators are a pain. So now that's 72 equals negative 2x. Divide by negative 2. If you need to use a calculator for these, that's fine. Okay. But negative divided by negative is a positive, and then 72 divided by 2, that's going to be 36. And then for question 2, for sure, if you want to use a calculator, do so with the decimals. And now you're allowed to round, it says, if you need to. So basically, kind of the rule of thumb, if an equation or an expression has decimals in it, then you can use decimals throughout. If it has fractions or doesn't have any fractions or decimals, then you have to keep it in fraction if required. So this is okay to use decimals, which I would, and your calculator if you need to. Okay, so those go to 0. So 4.2x, I'm just going to fix my sorry, what am I doing? 4.2x equals 4.44 plus 9 is 13.44. Divide by 4.2. And that's where you want to maybe get your calculator out. 13.44. Well, I could guesstimate that it's 3 point something. Yeah, it's 3.2. So use your calculator for that. No rounding needed because it's exactly 3.2. It's a terminating decimal. So in A, we added the constant term to both sides. In B, we are going to do the x term. So I'm going to get rid of the 6.5x on the left. And then 4 minus 6.5, okay, that's the x term. They're like terms. So that's going to be negative 2.5x. And divide by negative 2.5. It's going to be a positive. And again, so looks like it's going to be less than 2. 4.5 divided by 2.5 is 1.8. No rounding needed in that case either. Then question 4. Two terms with x. I'm going to leave the one on the right. I'm going to add 4.8x to both sides. And then divide by that coefficient of x, 2.3. something, I think. 7.3 divided by 2.3. Yeah, so this one we're going to have to round. It tells us to round to the nearest hundredth. Remember, we reviewed that last week. So that's 2 decimal places. Okay, so, oh, did I do something wrong? Yes, you're pointing at it. Good. I forgot to add the 4.8x, right? Rena, that's what you saw? Yeah. Yeah. Sorry. Yeah, just let me know. Sometimes I'm talking, but then I forget to write things down. So that's 7.1x. And then divide by 7.1. And so now find the decimal form of that. So it's going to be 1 point something. And to the nearest hundredth is 1.03. Okay. So in that package, you'll see the practice, both sides, and then 2 puzzle sheets. Okay, so that's your work for the weekend. Remember, we'll have a quiz on Monday. It won't include this. So you might want to go back into the other notes packages I've given you and do a sampling of some questions, right, just to refresh yourself. And timeline-wise, I'll just close this video off here, just a sec.